Welcome to a video on determining the inverse of a matrix using augmented matrices. If A is an n by n invertible matrix such that A times B equals B times A, which equals the identity matrix, then B is the inverse of A, denoted with this inverse notation. So let's go ahead and take a look at what happens when we find the product of these two matrices. First we have A times B, and then we have B times A. Now remember, usually matrix multiplication is not commutative, but let's go ahead and see what happens in this case. Now we're going to use the calculator because we've already covered how to multiply by hand. So we're going to press second matrix, go over to edit, press enter, and go ahead and enter in matrix A. It's a 2 by 2, and then we have the elements 4, 7, 1, and 2. Let's go ahead and enter in matrix B. Second matrix, go over to edit, and then down to matrix B. Again, it's a 2 by 2, and the elements are 2, negative 7, negative 1, and 4. Let's go ahead and find those two products now. Let's go back to the main screen, and then press second matrix A times second matrix B, press enter, and we can see that A times B is a 2 by 2 identity matrix. And now let's find B times A. And you notice that the product is the same. So since the product of these two matrices is the identity matrix, we can say B is the inverse of A. Let's go ahead and write this out. So what that means is that matrix B is actually the inverse of matrix A. So now what we'll do is take a look at how we find the inverse of a given matrix. And we're going to use augmented matrices to do this. So what we're going to do is we're going to create an augmented matrix in the form of matrix A on the left and the identity matrix on the right. So what we'll do then is perform row matrix operations that will result in the identity matrix being on the left side, and the right side will become the inverse of matrix A. So the main idea here is to convert matrix A on the left into the identity matrix, and then the right side will be the inverse of matrix A. Let's go ahead and give it a try. So if we want to find the inverse of this matrix, we'll set up an augmented matrix where the left side will be the given matrix and the right side will be the identity matrix. And since this is a 2 by 2 matrix, and we want to make the left side look like the right side. So we want a 1 here, a 1 here, and we want these two elements to be 0. So if we want to have a 0 in this location, the corresponding element would be a 3. The least common multiple of 4 and 3 would be 12. So what we could do is multiply this row by 3, multiply this row by 4, and then subtract them. So we're going to replace row 2 with 3 times row 2 minus 4 times row 1. And if we want a 0 in this location, the corresponding element is 3. The least common multiple of 2 and 3 would be 6. So we're going to multiply row 1 by 3, multiply row 2 by 2, and then subtract. So we'll replace row 1 with 3 times row 1 minus 2 times row 2. Let's go ahead and do that and see what happens. So we're going to have 3 times 3 minus 2 times 4. That's 9 minus 8. That's 1. Here we're going to have 3 times 2. That's 6 minus 2 times 3, which is also 6. 6 minus 6 would be 0. And here we'd have 3 times 1 minus 2 times 0. That'd be 3. And here we'd have 3 times 0, which is 0, minus 2 times 1. That's negative 2. Now let's take a look at row 2. We'd have 3 times 4 minus 4 times 3, that's 0. And here we're going to have 3 times 3, that's 9, minus 4 times 2, that's 8. 9 minus 8 would be 1. And here we have 3 times 0 minus 4 times 1, that's negative 4. And then lastly we have 3 times 1, that would be 3, minus 4 times 0, it's still 3. So notice now the left side is the identity matrix, which means now the right side should be the inverse of matrix A. Let's go ahead and write this down and then we'll test it on the calculator. So A inverse should be 3, negative 2, negative 4, 3. Remember from the previous screen, this means that A times A inverse should equal the identity matrix, and A inverse times A should also equal the identity matrix. So let's go ahead and check this. Go to enter in the given matrices. So second matrix, go over to edit, press enter, and we're going to enter in matrix A here, 3, 2, 4, 3, and then we'll put A inverse in matrix B. Okay, let's go ahead and find these two products. So matrix A times matrix B, and that checks out. And let's go ahead and find matrix B times matrix A. And we have found the inverse correctly. Let's go ahead and see if we can find a 3 by 3 inverse matrix. So now we're going to have a 3 by 6 augmented matrix. So we have matrix A on the left, and we'll have the identity matrix on the right. So we want the matrix on the left to become the identity matrix. So we want these three elements to be 0, these three to be 0, and then all of these to be, and then the main diagonal to be 1s. So if we want this element here to be a 0, we could add it to row 2. So let's go ahead and replace row 1 with row 1 plus row 2. And if we want this element here to be a 0, we could multiply it by 2 and then add it to row 1. So let's replace row 2 with 2 times row 2 plus row 1. So adding row 1 and row 2, we'll have 1, 0, 1, 1, 1, and 0. And now multiply row 2 and then add it to row 1. 2 times 0 plus 1, that's 1. 2 times 1 is 2, plus negative 1, that's 1. Here we have 2 times negative 1, that's negative 2 plus 2, there's 0 there. 2 times 0 plus 1. 2 times 1 plus 0, that's 2. And 2 times 0 plus 0 would still be 0. And we left row 3 the same. Now if we want to get a 0 here, we're going to have to work with row 3, otherwise we would lose this 0 here. So let's multiply row 1 by 2 and then subtract row 3. So 2 times row 1 minus row 3 would give us a 0 here. And then going down to row 3, if we take row 3 and subtract row 1, we'll get a 0 here without losing this 0 here. So let's go ahead and do that. Row 3 minus row 1. So 2 times 1 would be 2 minus 1, that's 1. 2 times 0 would be 0 minus 0, still 0. 2 times 1 is 2 minus 2, there's a 0. 2 times 1, that would be 2 minus 0, that would be 2. 2 times 1 would be 2 minus 0. And 2 times 0, that's 0 minus 1, so we have negative 1. Second row stays the same. Third row is row 3 minus row 1. So 1 minus 1, 0, 0 minus 0, 2 minus 1, 1, 0 minus 1, negative 1, 0 minus 1, that's negative 1, and then 1 minus 0 is 1. Okay, we're close. You can see we have a main diagonal of 1s. We have 0s here. We need this element here to be 0. So what we'll do is, we'll replace row 2 with row 2 minus row 1. We're out of space here, so what we're going to do is see if we can squeeze it in over here on the left. Row 1 and row 3 stay the same. And so again, we have row 2 minus row 1, so we have 1 minus 1, that's 0. 1 minus 0, that's 1. 0 minus 0, that's 0. 1 minus 2, that's going to be negative 1. 2 minus 2, that would be 0. And then 0 minus negative 1 becomes a positive 1. So again, the left side is now the identity matrix. The right side should be A inverse. 2, 2, negative 1, negative 1, 0, 1, and negative 1, negative 1, and 1. We're a little bit short on time, so you may want to go ahead and test to make sure that A times A inverse and A inverse times A does equal the identity matrix. I've already done that, and it does check out.